All right. Hi, everyone. Welcome back to my channel. So today, I thought I would go over a few NMR spectral problems. So I thought it would be a good example for us to get introduced to what NMR is, how to interpret NMR, and how to look at the NMR and basically propose a structure. So for this problem, it's quite easy because you're given the structure of ethyl acetate, which is quite simple and very easy. So we are now looking at the HNMR. So this is the structure right here. Um, so for NMR, in order for you to determine the splitting pattern of a particular hydrogen substituted carbon, you want to look at the nearest neighbor. So if we are looking at this CH3 group, we're going to look at this one to determine what the splitting pattern of this will be. So since this carbon doesn't have any hydrogen, this was going to be N+1, which is going to be just 0. So it's always N+1. N is the number of hydrogens of basically the next of the near carbon. So in this case, this is going to be 0 plus 1, which is 1. So this is going to be basically a singlet. So let's go ahead and look at this one. So if you want to determine the splitting pattern of this, we're going to have to look at the neighbor, which is a CH3 group. So doing that N+1, which is equals to 3 plus 1, which is 4. So we should have a quartet. And then let's go ahead and do this. So this one is a CH3 group. So for this, we have to look at the neighbor, which is the CH2 group. So you do 2 plus 1, which will be 3. So again, for this one, N+1, which is going to be 2 plus 1, which is going to be a triplet. All right. So that's that. So now we have that assigned. So now we also have to look at chemical shift. Okay. So this CH2 group, it's going to be a quartet, but it's next to an oxygen. So it should be roughly a little bit more downfield than the other CH carbons. So for this one, it will be A. So A will be basically, if we draw the molecule again, that will be this one. And then let's go on to B. B is just a singlet. It's integrating as 3. So we know that we should have a singlet here that's integrating as 3. So this will be B. Then let's go to C. C is a triplet integrating as 3. So we know what that is. That's going to be the other CH3 group. So that would be this one. All right, so now we got all of the 1H NMR assigned. Let's go look at the carbon NMR. So again, looking at carbon NMR, for this one, I think it's important for us to go look at the HSQC. So the HSQC, it's basically at hydrogen and carbon basically correlation. So looking at those two. So we already been lucky that we know that A has already been drawn out for us. So I'm going to go ahead and draw the full molecule for us. So we know that this is A. And then if you're looking at the HSQC, we see that A see a coupling with 2. Okay, so that's that. So then let's look at B and C. So we see that B, if we draw a line, we see a coupling with 3. And then C, we see a coupling with 4. So what this is telling us that that the B is basically what we see on the proton. It's correlated with this carbon. And then the same thing for C. B is correlated with 3, and then C is correlated with 4. So going back to our regular proton NMR, we can now tell that 4 is this, 3 is this carbon, excuse me, 3 is this carbon, and then 2 is this carbon. So just looking at the HSQC, we were able to correlate it. So now we have fully assigned the C13 NMR. So I want to look at this ATP. So this ATP basically helps us kind of figure out which ones are CH3, CH2s, and then CH, and then C. So if you look at the the ATP, it says that CH3 and then CH2 are all pointed up. These are all CH3s, CH3, so that's what these are pointing out. And then CH2s and CH are all down. So we know that this is the CH2 group, and then we know that this is C. So another way of us confirming our product, which is the ethyl acetate right here, where it went through. So yeah, that is pretty much it. I just wanted to kind of go over an NMR, how to look at the proton NMR, how to look at the carbon NMR, how to look at the ATP NMR, how to look at the HQC NMR, and then put that all together to sign an NMR spectra. Thank you so much for tuning in. Please don't forget to like, share, subscribe to this channel, and I'll see you guys in my next video.